of which is the continuation of the previous lesson. So I would like to find out from you, which chapter are you doing from school at the moment? On which chapter are you in right now at school?
We're doing this one.
You are doing what?
Trigonometry, this one.
Oh, trigonometry, the one we are currently in, right?
Yes.
Or no. So it means we can continue on that topic for trigonometry. So I want to show you how we deal with some of the questions on trigonometry or under trigonometry. So,
We're
but
doing special angle.
sorry.
We're also doing special angles.
Also special angle. Yes, yes. That part I'm gonna cover with you today of how do you find the special angle. So you need to know how you deal with a special angle. um, so now the first thing which I would want to remind you is what the trig ratios. Have you heard of the trig ratios before?
Yes.
Yes. So can you tell me the trig ratios we come across under trigonometry?
Sine, cos,
So sine, cos, and
tan.
tan, right?
Yes.
So if we write this trig ratio in terms of fraction, we know sine is the same as opposite over what?
Hypotenuse.
Over hypotenuse. And cos of theta is equal to what?
Adjacent over hypotenuse.
Over hypotenuse. And then tan of theta is equal to what?
Opposite over adjacent.
Opposite over adjacent. So you must not forget that. It's very, very important. So this comes only when you are given a right-angled triangle. This. So whenever we are given right-angled triangle, and then that angle is there, the angle theta is there. So the very first side which we must know is the opposite side, opposite to angle theta. It means opposite to that angle theta. We can have it as the opposite there, and then down here we can have the adjacent. What will be this line?
Hypotenuse.
That will be adjacent. And usually to represent the adjacent, they usually use letter X. To represent the opposite, they usually use Y. And to represent hypotenuse, they usually use what?
R.
This sine of theta, we can write it as Y over R, right? How can we write cos of theta?
X over R.
Is X over R. And how can we write tan of theta?
Y over X.
So it is Y over X. So that is all about the trig ratios, of which the important thing which you must take note of is this triangle we have here. At all time, it must be a right angle triangle. Can any one of you tell me, how do you know that the triangle that is given is a right angled triangle?
It has a 90-degree angle.
It has a 90-degree at all time. So is this 90-degree that you have there? So whenever a triangle is given a 90-degree, then you must know it's a right angle triangle. And when you have right angle triangle, that's when you can use trig ratios. Trig ratios, you cannot apply them if we are given a triangle which is not right angled triangle. All right, then now point number 2 is about what is called the Pythagoras. Have you heard of the Pythagoras before?
Yeah.
So can you give me the formula that represents the Pythagoras? The Pythagoras.
X squared
So it's x squared
plus y squared
plus y squared equal to
r squared.
r squared, right?
Yeah.
Wherein x is the adjacent, y is the opposite, and r is what?
Hypotenuse.
Is hypotenuse, yes. So then from there, after having the Pythagoras, we can have what is called the identity. And in your grade, I think you only do one identity, which is tan of theta. So tan of theta is the same as sine of theta over cos of theta. Have you come across this before? Yes. So tan of theta is equal to sine of theta over cos of theta. Are we in the same page?
Yeah.
All right. And then from there, number 4, we have what is called the special angles. This is the important one, wherein you must know how to deal with what? With the special angles. So special angles, we apply them when we are not given a right-angled triangle. So if we are not given a right-angled triangle, then we have to apply the special angle. Even in a situation where we are given right-angled triangle, then special angle can also work. So let me use a special angle when we are on the right-angled triangle. So, and we say on this right-angled triangle we have here, so we are given an angle of 90, which makes that to be a right-angled triangle. We were given an angle of 30 degrees. And then up here, we're given an angle of 60 degrees. It's the HOD. Can I pick this one? Just give me 2 minutes. All right. I was still explaining about the special angles, of which I believe most of you are interested to hear about these special angles. So they are not difficult, but they are very interesting. So special angle for when we are given 30 degrees here and a 60 degree up there. So the special angle that we're going to have here, we're going to have a 1 here and a 2 there. So we have a 1 here and a 2 there. If we're having a 60 degree here and a 30 degree down there. So now let's just give an example. We have cos of 30. According to this information here, what are we going to have for cos of 30? Okay, let me also write the value for down there because we have this value here and the value there. Then let me also write the value for down there. What are we going to have? So we're going to have root of 2 minus 1. Let me check that with it. All right, yes, here is root of 2 and then here is 1. Cos of 30, it must be root of 3 over 2. Cos of 30, it must be root of 3 over 2. So which means here is root of 3 and then there is 2. So this is how we have a special angle. So this first special angle here is for when we are given a 30 degrees here and a 60 degree there. So on the opposite, we must have 1. On the adjacent, we must have root of 3. And then on the hypotenuse, we must have 1 there, of which you can use a calculator to prove this. So cos of 30 is equal to root of 3 over 2. Can you tell me what are we going to have for tan of 60 degrees? Tan of 60 degrees will be equal to what? As according to this shape we have here. So tan of 60 will be equal to
1 over root of 3.
Tan of 60 will be equal to
Oh,
can you repeat that again?
1 over root of 3.
All right, so that is a good try. So but now we first have to check where is this angle here. So this angle is up here, you see that? So the opposite side to this angle is root of 3 and then the adjacent is 1. So because tan of 60 is different with tan of 30 degrees. So for 30 degrees, that was going to be correct because the opposite angle to this 30 degree is what? It's 1, right? So we're going to have 1 over root of 3. If we have 30 degrees, it was going to be fine. But now we have 60. Can you tell me what are we going to have when we have tan of 60? Tan of 60, what is the opposite side to this angle 60 degrees?
Of 3.
It's a root of 3. And then the adjacent? Adjacent is 1, right? So it means the answer of this is root of 3. Do you see that? Yeah, that is how you get to the answer of these questions. That is how you get to the answer of these questions. So that's the first special angle. Now we also have a second special angle. So the second one is very simple. It's when you are having a 90 degree here and up here you have 45 degrees. And for sure, this side you must have 45 degrees. So these three angles, when you add them together, they must give you 180 degrees because angles inside the triangle, when you add them up, they must be equal to what?
80.
Is 180, yes, definitely. So 90 plus 45 plus 45 is 180. Same here. If you add 90 with 60 with 30, it must give you a 90 degree. So then in this case, we want to check for when we have a 45 degree. So if we are having a 45 degree, so it means here we have to have a 1, and then we have a 1, and then we have a 2. So can you tell me what are we going to have for cos of 45 degrees? So cos of 45 degrees will be equal to what? What are we going to get for cos of 45 degrees? Any attempt?
Which 45? The top one or the bottom one?
For this one? So you can use whichever. So 45 here and the 45 there is the same. You can decide to use whichever 45.
Mm,
Okay, let me do that for you. We are going to use both of them so that you can see how we deal with this. So now, let's start with this 45 we have down here. What is the opposite side to this 45? The opposite side to this angle here is equal to what?
One.
It's equal to 1. And what is the opposite side to that 45? I mean adjacent.
1.
It is equal to 1. Very true. So now it means cos of 45 when we're using this 45 here. So we find the adjacent of that side, which is 1, and the hypotenuse side. Can you tell me what value of the hypotenuse do we have for that side? For that angle 45?
Root of 2.
It's 2. It's 2 as it is. Ne? And then now let's use this one. If we are using this one, what is the adjacent side to this angle here?
1.
It's a 1. Therefore, it's 1 divided by 2, which will give you exactly the same thing when you are using this other angle that we have on the other side. Is that clear? Is that clear?
Yes.
All right. Before I go forward, can you tell me what you did not understand on what we have on the board so that I can repeat for you before I wrap? Because we are going to just last part of the trigonometry. I want to do the last part of the trigonometry, which is very interesting and very good. Like it's a good chapter which you must understand. Are you fine with everything we have on the board?
Mm.
All right. So now let's do the last part of trigonometry for grade 10. Very interesting. So, oh no, we still have general solution. So we'll have to do general solution. So now we are having number 5, which is called the reduction angles. Have you heard of the reduction angles before? Have you heard of the reduction angles before? Or is for the first time you come across the reduction angles? Have you heard of the reduction angles before?
Yes.
All right, so that is what I'm going to cover with you now. So So the reduction angles on trigonometry is given in a Cartesian plane. So these lines, they form what is called a Cartesian plane. So they are 90 degrees to each other. They form an angle of 90 here. So if you measure the angle from this line to that line, it's a 90 degree. So then now here on the line exactly we have a 0 degree. Can you tell me what are we going to have up there if this is a Cartesian plane? Which angle are we going to have up there?
90.
We're going to have a 90 degrees. And then this side we have 180 degrees. And down there we have 270 degrees. And here exactly where we have 0, we have 360. So then now, this we call it a first quadrant. That is a first quadrant, and this is a second quadrant, and that is a third quadrant, and that is a fourth quadrant. So there are values which, there are trig ratios which belong to first quadrant, trig ratios which belong to second, to third, and also to fourth. So let's start with trig ratios that belongs to first quadrant. So all the trig ratios, sine, cos, and tan, they are positive on this first quadrant. All trig ratios, sine, cos, and tan, they are positive on the first quadrant. Can you tell me which trig ratio is positive on the second quadrant?
Sine.
Which one?
Sine.
The sine. Sine is positive on the second quadrant. And then on the third quadrant, which one is positive?
Tan.
It's a tan. And then for sure on this quadrant, what is positive? Cos. So on the first quadrant, we have angles that we must adhere to. Can you tell me the angles that belongs to the first quadrant? Can we have the angles that belongs to the first quadrant? Is 90 minus theta, right? Yes, because 90 is the maximum angle. So in order to generalize all the angles inside the first quadrant, we say 90 minus theta, where theta stands for any angle that can be in the first quadrant. And then on the second quadrant, it must be 90 degrees plus theta, because we already passed theta here. In order to belong to second quadrant, so it is this 90 we get here, and certain angle that we can get on second quadrant. That's why we say 90 degrees plus theta. And the other angle that belongs to second quadrant is 180 minus theta, which means in this case we rotate, we go to 180. So in order to be on the second quadrant, then it must be 180 minus any angle which is on the second quadrant. And then on the third quadrant, can you tell me the angles we can have on the third quadrant? Which angles do you?
180 plus.
It's 180 plus. It's 180 degrees plus theta. Can you tell me the second angle we can have on the third quadrant?
270 minus theta.
Is 270 degrees minus theta. And then the angles we can have on the fourth quadrant?
270 plus theta.
Yes, that's the first one. And then the second one?
Minus theta.
Is 360 degrees minus theta. We don't have 2 here, we have 3. Can you tell me the last angle we have on the third quadrant? On the fourth? Is minus theta, right? Yes, let me explain that last angle we have there. So all the other angles you indicated here, we obtain them when we are rotating to anti-clockwise direction. So all the angles we obtain, we had to rotate to anti-clockwise direction. But now if we decide to rotate to clockwise direction, so you'll see here we're going to have a negative theta, because below the x-axis, this is the x-axis. Below the x-axis, we have negatives. Above the x-axis, we have positive. That's why on this quadrant, we have negative theta. Is that clear?
Mm.
Yes, so you must not forget all these things. So then now we have, that is a reduction angle, but on the reduction angles, I would like to experiment some angles before we move further to what is called the core ratios. So on the reduction angle, let's say we have sine of 180 degrees plus theta. So we must explore this. So this is how you attend to the angles on the reduction angles. So you go and check, where do we find 180 plus, or on which quadrant do we find 180 plus? Can you tell me which quadrant do we find 180 plus?
The third quadrant.
It's on the third quadrant. And on the third quadrant, which trig ratio is positive? Is tan, but here you will see that we have trig ratio of sine. So therefore, the answer we obtain on this one is going to be negative sine of theta. So you write it like that. So you no longer write 180 plus, so you just write negative sine of theta. Let me give another example of cos of 180 degrees minus theta and cos of negative theta. So 180 minus, we find it on which quadrant?
The second quadrant.
Second quadrant. And which one is positive on the second quadrant?
Sine.
Sine. But what do we have there?
Cos.
Cos. Therefore, the answer we get is going to be negative cos theta. Then let's attend to the last one. So negative theta or negative angle. On which quadrant do we find negative angle?
The fourth quadrant.
Fourth quadrant. And which one is positive on the fourth quadrant?
Cos.
Is cos. And what do we have on that question?
Cos.
Is cos. Therefore, we're going to have positive in that case, because we have cos. If we had sine, it was going to be negative. So that is how we deal with reduction angles. So on reduction angle, we also have what is called the core ratios. So we must know how to deal with core ratios. So what are core ratios? Core ratios are 90 degrees and 270 degrees. These are the only two core ratios you can come across, of which, in order to deal with core ratios, this is what happens. Let's say we have cos of 90 degrees minus theta. So core ratios, if you are given a core ratio like here, we have 90 or 270. So core ratio changes cos to what? To sine. Or it changes sine to what? To cos. Is that clear?
Yes.
So let's do this so that you see what happens. So again, you check on which quadrant do we find 90 minus?
The first quadrant.
Is first quadrant, and on first quadrant, all of them are positive, right?
Yes.
So it means we're going to have positive answer. But here we're not going to say cos of theta, because cos, if we are having core ratios, cos changes to sine. Therefore, we're going to have positive sine theta. Why it changes to sine? Because we have what? Core ratio of 90. Is that clear?
Yes.
Let me give second example where we have cos of 90 degrees plus theta. So in that case, you check on which quadrant do we have 90 plus. 90 plus is on the second quadrant, right?
Yes.
And which one is positive on the second quadrant?
Sine.
Is sine. And here we have cos. Therefore, we're going to have a negative. But now, because it's a core ratio, so it means cos changes to sine, and we now have negative sine theta. Do you see how we are attending to these trig, reduction angles and core ratios?
Yes.
So now, as a homework, I just want you to go and identify 3 questions that involve anything that we have covered today. So you go and identify that, do it, and then send to me so that I can see if you are understanding this thing. Just 3 questions. Do 3 questions, and then when you are done, you send the question and the solutions you obtain so that I see if you are doing this in a correct way. Is that clear?
Okay.
Yeah. Otherwise, from my side, we are done, and have a great day.